This is John from caveofprogramming.com. In this tutorial we're going to look at how we can ensure that our game or our simulation runs at the same speed on every computer that it runs on. So at the moment we've got this particle explosion. It doesn't look very good. We can see the individual pixels here. I don't know if you can see them on this actual video, but I'm sitting here and I can see the individual pixels. They don't look kind of smoky or blurry or anything, so it doesn't look that great. And they also form a circle that's a bit too perfect. They're all changing colour at the same time and they're not really doing anything too interesting. But what we have got is we've got a circular explosion, at least. Now, one problem with this that's kind of hidden in that you won't necessarily notice it immediately, but it is there, is that this is just running as fast as it can, depending on how fast the loop that we've got in main, the game loop, can iterate. So on a really fast computer, this explosion will happen really fast. On a slower computer, really slow. So what we'd like to take account of the time in such a way that this runs at a similar speed on all different computers that it runs on. What we need to do is, in our particle.cpp here, this is where we are actually moving. We're actually moving the particles. We need to move the particles every time the loop iterates by an amount that's proportional to the amount of time that has passed since last time the loop iterated. So let's have a look at and see how that actually pans out. I'm going to go to main.cpp here. In main.cpp we've got the amount of time that has elapsed since the program started running, and the first step is I'm going to supply that to this swarm.update, the swarm class that manages our particles, so that it knows what the time is basically. Let's put an elapse to this swarm.update, and let's go to swarm.h, change the prototype here to take a integer value, the number of milliseconds that has passed since the program started. And in the implementation as well, we'll also add that. Now, what I really want to tell each particle as I iterate through it here in the swarm update method, this is where we're iterating through all our particles and updating each one individually. I want to give it the amount of time that's passed since last time update ran. So to do that, we need to store the time, the number of milliseconds that had passed since the program started last time this update method ran, and then we can compare that to the number of milliseconds that has now passed when we're running update this time, and subtract one from the other, and we can get the interval that has elapsed since last time the update method ran. I'm going to go to swarm.h here, and let's give this a private variable called int. Let's call it last time. In the constructor of swarm.cpp here, in the constructor initialization list, I can initialize last time to 0. And in elapsed here, every time we've finished using this update method, I'm going to set last time to the total number of milliseconds that has elapsed since the program started running. When I first go into update, I can then say int interval equals elapsed minus last time. So this again is I don't know of a name for it, but it's a common sort of design pattern that we have where we're getting an interval and using it to find out how much time's elapsed since the last time we got that interval, or it could be some other value, and then we're storing the present value of this interval, of the time. We're storing the kind of present time, so that next time we can get the interval again using the time that we just stored. So now that we've done that, we can pass the actual interval to particle.update. Let's pass that in there. And I need to go to particle.h, and in the update method here, let's give it an interval. And in particle.cpp, let's change that as well. So int interval. And now all I have to do is when I add the speed to the x and y coordinates, I need to multiply those speeds by the interval, and that will ensure that the amount that we move each particle by when we run the update method is proportional to the amount of time that's passed since we last moved the particle, thus ensuring hopefully that it will move at a similar speed on slower systems. On a slower system now, its movement could be jerky, but at least it's gonna be a similar amount of movement to what we'd find on a faster system. And usually for games, that's what you want. You don't want things to be just running at whatever speed they happen to run at. You want them to run at a consistent speed. You'd rather have jerky motion on a slow system than have the game just running really slowly. And it's equally bad, especially for a game, if you've got something that runs really fast on a fast system, too fast for the user to respond to in a game. So this really helps sort things out a lot. So let's make sure everything's saved and build the project. I've got an error here, but I'm hoping it's going to go away. Let's take a look. Well, I don't see any errors. Yeah, so the error's gone away now, so that's good. Let's run this and see how it looks. Might be a bit fast or slow. Yeah, it seems very fast. So let's go to particle.h, particle.cpp maybe. And here we're creating the speed that we want the particle to move at. Let's just put another decimal place after the point in here to make the speed slower, because I want to slow this down so we can really see what's happening. There we go, that's a lot better. Now we can see the circle forming. So we've still got quite a bit of work to do here, although we're approaching the end of this now. So I'll leave it there for this tutorial, and until next time, happy coding.